Hello, welcome back to Cracking the Cryptic. The last time we had James Kopp having a puzzle on the channel, it was his 7-year-old grandson's birthday, I think. Isaac, if I remember correctly. And wow, great for Isaac to have a grandfather setting puzzles for Cracking the Cryptic. Well, I hope so. Maybe Isaac is entirely untroubled by it, as many 7-year-olds would be, if I'm honest. But James has sent us another puzzle called Polygons today. And we do have a variety of different, well, we have a number of triangles. In fact, we have 4 triangles, 4 squares and 4 pentagons in a variety of colours. Is it 2 of each in each category? Yes, it is. Okay, so I'm looking forward to giving that a go in a moment. First of all, now on Patreon, we now have my super hard crossword solve as of today. The Times Monthly Club Special does a cryptic that is just insane, and I have a go at it every month. I've for some reason been sitting on that video for some time, but it's gone up on Patreon today, joining Simon's incredible solve, much more interesting in some ways, of Fistomafel's puzzle Skyscraper. I have watched the video and it is remarkable. And I do recommend it if you like watching Simon battle Fistomafel, and frankly, who doesn't? So those are on Patreon, and Patreon's a great place to go, and we've got a new reward coming out in 4 days' time on the 1st of June, and you will love it, guaranteed. And of course, you will love our apps, which are available on the links under the video. You will also love our merchandise if you manage to get hold of some, and Sven's SUDOKU PAD. And they're all on the links under the video below the link to Polygons by James Kopp. And I'm going to go through the rules now. So, normal Sudoku rules apply. 1 to 9 going in every row, every column, and every 3x3 box. Hurrah! Adjacent digits along an orange line have a difference of at least 4. So they are Dutch whisper lines, the most normal form of orange line we use, I think. So box borders divide the blue lines into regions that have the same sum. So this digit will be the sum of those two. These two will be the same, and the sum of those 3, etc. Within a cage, digits don't repeat, and they sum to the small clue in the corner of the cage. And that is the set of rules that we're operating with. Do give it a try on the first link under the video. I am going to reset my clock and say those magic words. Let's get cracking. So let's hope the magic words help us get cracking. I don't know where to start in this. I'm just going to study it and think about that. Okay, I'm going to talk very briefly. No, not very briefly. No, I think this is actually very helpful. Okay, orange lines, Dutch whispers. They don't alternate like German whisper lines do between high and low automatically, but they nearly do, and that's very important. What on earth are you talking about, Mark? I hear you say. What I'm talking about is as you go along an orange line, the only way that you're not going from a high digit higher than 5 to a low digit lower than 5 and then continually alternating between those is if you actually hit the number 5 itself. When you do that, obviously you can go to either 1 or 9 on either side of the 5, but that's the only way you can change the alternation of polarity as the fanciest term we could come up with for that. But what it means is that these triangles are actually, I think, very helpful. To go, imagine this was low. Well, wouldn't both of those digits have to be high? But how could 2 high digits sit next to each other? And they couldn't unless we allow for 5 to be high in one context and low in another. What I'm saying is, actually what I'm saying is for an orange line to join up with itself, as all of these do, they form continuous lines, and to have an odd number of segments tells me that there must be a 5 on that line. And indeed, these little triangles must be 1, 5, 9 sets. There is no other way to make them up. So that is the case. It doesn't tell me anything about the order in which they appear, because any of those two numbers can sit next to each other. But it does tell us that these numbers are made up of 159. So we've got a 159 triple in row 2. Now it does also tell us that these sort of luggage tag pentagons have 5 cells as well as 5 sides, and therefore this rule does apply to them. There must be at least 1 5 on them. And I do say at least 1 5 because in theory these shapes could have 2 5s on, as long as the 1 5 changed the polarity between high and low and the other one didn't. But I mean, I think that vaguely is possible. If we had a 1 here, 5 here, it probably isn't possible. The 2 places for 5s would have to be there and there on this one. Yeah, no, that would work in theory. No, it wouldn't in practice. Not on that one. Actually, it's very hard to be sure. I think those could both be 5s. And then you could have 1 1 9. Actually, that would work weirdly on this luggage tag. Anyway, they must have at least 1 5 on. I'm going to try and remember that about them. Now, these digits are the sum of these 3. Each of them is the sum of those 3 based on the blue line rule. So they're at least a 6. And they are the same as each other. And that's quite interesting, because if they're not 9, where does that digit go in this box? It goes there. I think the Dutch Whispers are the place to carry on working at the moment. I'm not sure, actually. And James doesn't set very easy puzzles normally, so we're just going to have to be a little careful. Neither of these digits can be a 9, because they both see 159 triples. And we can't have a 1 here, so these add up to at least 5 by being 2 and 3. That can't be 5 and it can't be 9, so it's 6, 7 or 8. This one similarly, well, these could have a 1 in those, so I can't do quite as well with that triangle as with this one. Oh, I should maybe think much harder about cage totals. Obviously here in this 18 cage, the 2 sides each add up to 9 because of the blue line. But that's all I really know down there. And here that each side adds up to 12. Now, the 17 in a single cage with that orange line going through them, what are the minimum digits? You see, we're not going to have a 5 in here because the digits have to change in this cage. We have to have 4 different digits in it because it's all in the same box. So we're not going to have a 5. So we're going to have 2 higher digits and 2 lower digits. Now the minimum high digits are 6 and 7, adding up to 13. The minimum low digits are 1 and 2. That takes us to 16. So there's 1 degree of freedom there. So the low digits must include the low digits must include a 1. The high digits must include a 6. And the selection of digits is taken from 1, 2, 3, 6, 7, 8. And there's definitely a 1 there, and there's definitely a 1 there, and that's a sort of X-wing. It means the 1 in column 3 is going to have to be down here somewhere. Which doesn't really, I mean, it's on a line, so it's interesting, but we don't know what it is. And those add up to 12. Oh, and we know these add up to 17, obviously. So now I share the secret with you, the secret of every row, box and column in a Sudoku, which is they all add up to the same thing. And I can even tell you the number, but be careful, guard the secret. It's 45. So anyway, 17 there and 12 there is 29. These add up to 16. And of course, that is not a very helpful number. 12 there and a maximum 9 here is 21. 23 is a very middly number compared to 17. I'm not really going to exercise myself with wondering what the digits are yet. I mean, I'm going to have to, obviously, at some point, but not now. Yeah, I don't really know where to go. There's a 1, this is either 1, 3, oh, if this was 1, 3, 6, 7, 3 would be next to 6 somewhere. And that's illegal on the Dutch whisper thing, so it's not. It is 1, 2, 6, 8. Yes, so we've worked out. Because the high digits have to border the two, each high digit has to border the two low digits. So each low digit has to border two high digits. So if we used 1 and 3, then we could only use 6 and 7 as the high digits, and 3 would border 6. So that doesn't happen. So I've narrowed this down to 1, 2, 6, 8. Now this pair that adds up to 12 can't be 8, 4. It's either 3, 9 or 5, 7. And there is a 4 in one of these cells along with the other pair from 3, 9 and 5, 7. We didn't find any more X-wingable numbers. And we didn't actually identify what these were, but still, it felt helpful. This digit, well, it is 3, 4, 5, 7 or 9. If it was 4, these would have to be an 8, 9 pair. And this would have to be a 5, 1 pair. And that's not possible because 1's over this side somewhere. So it's not 4. If it was 5, this would be a 1, 9 pair. And these could be anything they liked. That would be the 1. I've said there has to be a 5 on this luggage tag. Now, the reason there has to be a 5 is because there has to be a polarity change along it to have an odd number of cells that are in a sort of a circle, a metaphorical circle. But there is a corollary to that 5 needs to sit between a 1 and a 9. So in fact, there's not just a 5 on this shape, there's also a 1 and a 9 on it. Now there is only one place for 1 to be on it, since we confined 1 to those 3 cells and ruled it out of there. It's got to be here. So that's the 1, and that is sitting next to a 5 in one of these two positions. And the 9 is on the other side of the 5 in one of those two positions, ruling 9 out of those cells and putting it in there in the orange triangle. That can't be a 9. Now there's a 1, 5 pair there. We take 1 out of those cells. We know it's in these. Yeah, that's really interesting. This can't be 3 anymore because it's too near 1. It could be 7 though. If that was 5, 9, low, 7, I think that works fine. Oh, it can't be 9 since we put that 9 there. Right. This is either 7 or 5. If it's 7, we've got 5, 9. If it's 5, we've got 9. And then these can be sort of any low and any high. It's not strictly true, but it's not far off. Now, we've seen already there couldn't be a 1 on these cells. If this was 3, 9, there'd have to be a 2 on this pair. I can see that, but it's there is a 9 there and there's a 9 here, so there is a 9 in these 3 cells. So if that wasn't 3, 9, it would be 5, 7, which is impossible because of that cell. Ha ha! So that is a 3-9 pair. Okay, good discovery. These are now a 4-5-7 triple, of which that can't be 5 because of the 1-5 pair up here. 3-9 there. 9 here. 3. 3-9 there. We've got 1. I don't know which of these is a 5 still. Nothing's changed there. The 3-9 doesn't really feed across into these cells, which could theoretically still be a 3-9 pair themselves, although I think that would give us a uniqueness problem, but we wouldn't be proving the puzzle only had one solution, which is something we like to do. If we used it... there is a 9 up here, and there is a 9 in one of these cells. Is that doing anything for the 23 cage? I honestly don't think so. I mean, I suppose with 159 gone here, these digits are... One of them is from the population 2, 3, 4, and one of them from 6, 7, 8 to maintain the difference necessary. So they add up to somewhere between... I think it's quite a big difference. Between 6... Well, between 6 and 12. So these have to add up to at least 11. And it could be as many as 17. Well, now there are limits. It can't be 17 because 9 and 8 wouldn't have the necessary difference between them. So let's bring the maximum here down to 9 and 5 as digits equals 14. So the minimum here is 9. And I think we said the maximum is 12, isn't it, with a 4-8 pair. So these add up somewhere between 9 and 12. These somewhere between 11 and 14. And I don't think that works actually very helpful. Okay, let's go back. Oh, this one. 1, I don't know. No, this is fine. 1 is next to 6 and 8. 2 is also... There's nothing... As long as I checkerboard the low digits and the high ones, it'll be fine. Okay, that does mean since 1's in those cells, 2 can't be. 2 is the low digit needed in those. So there's definitely a 2 here. And that means that these 2 digits, which don't include a 5 or a 1 or a 2, but they do need a low digit, which is either 3 or 4. Now, the only way it could be 4, it couldn't be there touching 5 or 7. It would have to be here touching 8 there, with 9, 5 occurring. If the low digit is 3, this could go 7, 3, 9, 5, or 5, 9, 3, 7 or 8. But given that the low digit in these cells is now 3 or 4, the higher digit is at least 7. Oh no, we know that the high digit in these is 9. We've actually established that. Well, that's interesting. So these use a 9 and either 3 or 4. We've had 1, 5 here, definitely 2 here. If I knew that was a 4, then the low digit would be a 3 down here. It can't be a 4 in this cell. Yes, that's kind of what I was establishing earlier, because of the 5 or 7 here. But it can be a 4 here if that's an 8. And this would be a 2-8 pair, this would be a 1-6 pair. There are ramifications, but they're not really easy to pigeonhole. So what? I don't know. So they're not worth proceeding with. Now, 5 or 7 there. And this, yes, let's take the lesson I learnt over here, over to this. It doesn't just have a 5 on it. It also has a 1 and a 9 on it. And the 1 is not in those cells by Sudoku now. So the 1 is in one of those cells. If that was a 1, that would be a 1. This would be a 1-8 pair. You also wouldn't get a 1 into the 23 cage then, but I don't think it needs one at all. If the low digits were 2, 3, the higher digits would have to be 7, 8 at least, which adds up to 20. Okay, what if the higher digits didn't have a 9 in? That could be very interesting. I'd love to prove that the higher digits do have a 9 in. If the higher digits don't have a 9 in, then the most they can be is 8, 7, adding up to 15. Then we need the lower digits to add up to 8. And they're not, you can't have 3, 5. Right, I think I'm proving that there has to be a 9 in this cage, and I think this is the biggest deduction of the opening part of this puzzle. But bear with me, if you didn't have a 9 in this cage, the two highest digits you could put in, no, you see I've got it wrong. You could put 8 on both sides of this box border. Bother. And then, as low digits, you could have 3 and 4. Curses. I had forgotten that as we crossed the box border, we didn't need to exclude. I'd forgotten that we didn't need to have 4 different digits on here. It's really interesting, though, in a way. If you didn't have a 9, you can't have a 9 in those cells because we've got a 9 in one of those two. So if there is a 9, it's in one of these two. That stops this being a 9, which is quite powerful. It stops this being a 9, which resolves this 3-9 pair. I imagine it does a bit of other work. It keeps 9 out of those cells, which might turn out to be interesting. But there's either a 9 there, or I think there do have to be 2 8s. On this square, and that keeps 8 out of these cells, but also 8 out of those cells. Okay, it was set to be a big deduction, but it didn't quite happen. But it is still very interesting what this does. So this square's high digits either include a 9 or 2 8s. 8, 7 won't work because you'd need kind of 4, 4 as low digits, and 4 mustn't touch 7 on the orange line. Here's a thought. If these yellow digits were 9s, where's the 9 that needs to be on this luggage tag? It has to be there, with a 5 in one of those cells and a 1 in one of those two, which would have to be here. So we'd then have 1 and 9 there with 5 here. And that would be absolutely mandated. That's really interesting. So if 9 was in the yellow cells, we would know all about 159 on this tag. If 9's not there, then this group uses a 1. It adds up to 6, 7, or 8. There's lots of different impacts of 1 being on almost any of these cells. If it's there, we get a 1 forced there and a 1-8 pair here. If it's there, we get 1 forced there and into one of those two. 1 has to be somewhere on this luggage tag, but where? Oh, goodness. This is really interesting and very James Coppian in that I don't quite know what to do with the puzzle at the moment. There's so many areas where there's an almost deduction to take us forward. Oh, we've had a 3 here. Now, I did say earlier that that was definitely going to put a 2 into this pair, and that is true, because they can't just be 4, 5, because that would add up to too much for that. So there is a 2, and they add up to 6, 7, or 8. So this is either 2, 4, 2, 5, which it can't be, or 2, 6. So as it can't be 2, 5 because of this 1, 5 pair, that's not a 7. This is now 6 or 8. And that is either 2, 4, or 2, 6. And this pair now can't have 1, 2, or 3 on. It may not help much, but they have to add up to at least 9. Which is the same sum as those 3 by the rule. Ah, 4, 5, and 7 have to appear in this group of 6 cells. You can't have 2 of them on here. Because then you'd add up to too much for these. Even if it was 4, 5, there'd be another digit breaking these. So there's a maximum 1 of those 3 numbers in that group of cells. If that was 3, 9, there'd be nowhere to put the other 2 digits out of 4, 5, 7. They'd both have to go in there. That's not happening. So this is either 4, 8 or 5, 7. If that's 4, 8, then 5 has to go on this line and 7 in there. If it's 5, 7, 4 has to go on this line. That was interesting, but again, not decisive. Three, 9. Again, very close to a full deduction that actually moves us forward, but not quite there. It is quite an amusing puzzle in that respect, I have to say. I mean, it's nice not to have proved that that's not a 3, 9 pair by something other than uniqueness, so I'm settling for that for now. Now, this digit is at least 5, and it could be 6, 7, or 8. I'm missing something now. I don't know if you're shouting something at the screen for me. It would be useful if whatever you're trying to communicate does come through, because I am struggling a bit to find out how to do anything. Oh, 2 is in one of those cells and one of those cells. So now one of these 2 is a 2. Right, we worked out that 1 can't be in those 2 cells. So one of these 3 is a 1. 5 also can't be in those 2 cells, but must appear somewhere on this luggage ticket. So it's either there or in one of those 2. If 5's in one of those 2, then 1 has to be in one of these 2 touching it. If 5 is there, then this is actually a 1, 9 pair. So there's always a 1 in one of these 2 cells. I know I'm marking across boxes here, and I don't love doing that, but needs must when the devil drives, I suppose. So 5 is either there or in one of these, and therefore 9, I don't think we have as much certainty on 9. Could I rule out this being 5? Or maybe I need to think about the makeup of low digits here. Does it need a 1 on? I don't think it does at all. No, in fact, we worked out that 8843 was fine. I think trouble is putting 9 in. We can have 1 9, so 9 8 could be the high digits. Then you could have 2 4. I mean, I do think I'm coming to the conclusion that there has to be, that there can't be a 1 in this square. But actually that's not incredibly helpful even if I do conclude that, because we already know there isn't a 1 in those, so it would just keep 1 out of those. Now, what I'm suddenly thinking about now is the only way for this to be a 1 is for that to be 2, 3, 4, making 9s here. And if that's a 1, it's impossible, because from the 1 we have to go 5, 9 in that direction, clashing with the putative 9 there, or 5, 9 in that direction, clashing with the putative 9 there. So this is not a 1. We've found the 1, it's here. And then the 5 is in one of these cells, and the 9 comes next in one of those two, ruling out 9 from this cell, and telling us that yellow is not a 9. Yellow is 6, 7, or 8. And now there is definitely a 1 in this group of cells. Now that's not as helpful as it was before we knew that was a 1. But we now know there isn't a 1 here. In fact, I can place that 1 on the big diamond at the top. 1 there, 9 there, 5 there. This might get us going. I'm not sure it's going to, but at least I've got a lot more digits fully written in than I had before. We now know there isn't a 1 here, but we'd proved that a different way, hadn't we? I think so. We know there's a 9 in one of those cells and a 9 in one of those. They're not very useful cells to know that for. We don't know that there isn't a 1 somewhere here. We know there's a 5 in one of these, so this can't be a 5-4 pair, adding up to 9. In fact, there is a 1 in them now, so that is a 1-8 pair, and now yellow can't be 8 either. Yellow is 6 or 7, and now we get a 2 onto this, with either 3 or 4 to make up the 6 or 7 total. Whatever this yellow is, it now has to go here in box 1, and in one of those cells, and in one of those. Right, yeah, one of these digits is a 6. That's nice. This is either 2 plus 4 equals 6, or 2 plus 6 equals 8. So both yellows in rows 2 and 3 can't be 6, so they're 7. Brilliant. Oh, this is a fantastic puzzle, James. So 1, 2, 4 there. That's not 4, 8. It is 5, 7. Hasn't fixed this stuff, I don't think. 7 there, though, looks at this cell. Might as well yellow it. One of these is a 7. It feels very... it feels unlikely to be there, but I'm certainly not ruling that out yet. This pair adds up to 9, and they're not 7, 2. I don't know what they actually are. Negative information is, as usual, a lot less useful than positive. There's a 5 in one of those two. It would be powerful to be here. It would have to be with a 3 there, I think, making an 8 here. I know that's not what happens by uniqueness, because if you had 5 and 3 here, this would have to be a 1-8 pair, and that would cause a uniqueness problem in the end. But we're not allowed to use that because we're trying to prove that this puzzle has only one solution. Now, that can't be a 9 because we know one of those is. Therefore, the 9 in box 5 is in one of those 3 places. So I've now got 9 pencil marked in that column and in that row, and they overlap, which is messy, because that doesn't mean this has to be 9. How can I rule 5 out of one of these places? Is it really easy to do and I'm just not seeing how? Or now I know 7 isn't in this box. It could still be 8, 8, 4, 3. I don't think it can be 9, 6 because the other 8 would clash with the 6 somehow. Yeah. So if there is a 9 in the box right here, then the high digit on this side has to be an 8 because 9 and 7 are gone up here and we can't have a 6. 6 isn't big enough. So there is always an 8 in one of these two cells, whether there's an 8 in these two or a 9, there's always an 8 up here. Next to 2, 3, or 4. Oh, this is a 1, 9 pair, I've only just noticed. Now, 1, 5, 9. Why don't I know which one of these is a 9? I probably do, and I can't see it. How about this? I don't like this blue one. It just doesn't add up to enough to satisfy me. Getting loads done and still really floundering around a bit in the dark. I loved that deduction about 6s in rows 2 and 3 and there had to be 1 here, but it didn't lead on to anything, did it? This is 8, 2, 8, 3 or 8, 4. 1, 5, 7, 8. These are from 2, 3, 4, 6. Ah, so is this digit. This digit sees 5 in one of those places and 9 in one of those. Actually, it sees 4, 5, 7 across and 9 in one of those. So this is 2, 3, or 6. These are from 2, 3, 4, and 6, and that's now a quadruple. This one, of course, cannot... Ah, we've got a 1 in this box, so we can't have a 1 there. So this can't be 2, 3, or 4 now. This digit is a 6, by George. And these two are a 2, 4 pair. They don't include a 5. 5 is placed here. 2, 4 pair looks at that cell. Have I done something wrong? I do hope not. This is 3, 6, or 8 by Sudoku now. Now, that 2, 3, 4 triple, I haven't used it yet. This is a 5, 9 pair. Oh, that's really weird. That wasn't... So some number is repeated on here, and it's 9, because there's a 9 in one of these cells that's next to whichever of these is a 5. That's so strange, but it's not actually impossible, thank goodness, because that would mean I'd done something wrong. However, this now can't be 2, 7, 4, 5 or 1, 8. That is a 3, 6 pair. That digit is an 8. That keeps 8 out of those cells and makes sure 6 is in them as the high digit. 6 is not in those cells. Let's just get rid of the corner marks there. 8, 1, 3, 6. This column, that's a 5, 9 pair. What? Is 5 repeated on this as well? It can be, I think. Look at that. 9, because of that 5, obviously. 5, 9, 5. Well, I did say early on that 5 could, in theory, be repeated on the luggage tags. I rather thought it had been disproved later. But obviously it hadn't, because that one is all made up of 5s and 9s. Right, this digit becomes an 8 because of the 1 we placed there. So now I can rotate high-low around that square. This can't be an 8. Oh, do excuse me for a second. Oh, sorry about that delivery. It came at a very annoying time for me. Oh, look, where's the cursor? It's down here. We were presumably going to sort out this one. I've got a 9 there. That makes this cell a 3. Now, that's got to be helpful. That makes that a 7. These are a 5, 9 pair, and there they go. Done. That's a 4. That's a 5. Now, in this first column, we've got 7 and 8 to place. Don't know which way round they go. Is this not done? Don't think so. This is a 3, 6 pair. looking at that cell, which is 2, gives us an 8 there. That places 8 where I didn't think it was going to be in this box, and that high digit is a 9. So those add up to 17, and these add up to 6. They could be a pair of 3s. So I just have to be very careful before writing a 2, 4 into there. In fact, no, they can't, because 9 is looking at 3 there. So now that's a 4 and that's a 2. Is this adding up right? And it's obeying the Dutch whisper rule? Yes. So I think we're on the trail here, and very actually closing in quite hard on the finish now. Now let's look at this row. We know where 2 goes in that triangle. 2, 8, 7, 5, 1, 9. This is 3, 4 or 6 and actually not resolved. That 2 though is resolving 4 there, and that's going to get stuff done. Lots of stuff. We now got 2, 6 on the triangle and 8 there. 6 and 3 in box 2. That does 6 and 3 in box 5, of course. Let's get rid of the yellow marking on the 7s. And 4, 8 and 7 to place. So we're still going to have to use the blue luggage tag down here. Now, oh, that's a naked 4. Oh, it's gone green. That's a 4. So there is a 4 down here. This pair is either 4, 7 or 4, 8, adding up to 11 or 12. Let's just put in the candidates here. That is 2 or 4. 1, 2, 4 or 9. 11 or 12 is the tally of this group of cells. If that was a 1, that would have to be 2 and 9, making 12. That's the only way you could get up there and not go too high. If that was a 7, 4 and 1 would make 12. And if that was an 8, 2 and 1 would make 11. Oh, bother, I thought we were going to get it done that way. It got too complicated and it blew my head off suddenly. This is a 2-6 pair. Let's put that in. Basic Sudoku, I'm much more comfortable with that than case testing luggage tags. 1, 7, 8 or 9. Now, have we got a triple forming along here? Not quite. No, not quite. Oh, I'm going to have to go back to case testing this luggage tag. It's strange though. There is something happening though. How does it work? Okay, let's say that was 4, 7, because there seemed to be only one possibility of achieving 11 with these digits, and I think it's 1, 2, 8, 1. 7 can't occur because you'd need a 3 on the line, and that's not happening. 9 can't occur. So if that's 4, 7, this has to go 2, 8, 1, which fixes 8 and 1 here. But now you've got 8s in both of those areas. Oh, the simple fact is that there is an 8 in one of those cells and there is an 8 in one of those cells, so that's not 8. In fact, nor is that. 8 in this row, in fact, is fixed. That's how easy that is, because those 8s keep them out of those cells, so that's an 8. Now there is no way for this to be 4, 7, because there's no 11 sum available here anymore. It just can't be done. That's so interesting. So that's a 4, 8 pair. 7 there. These add up to 12. Now there were a couple of ways for that to be done, so I'm not going to rely on that to finish the puzzle. I'm going to use this 7. That puts a 7 here. And now these two have to add up to 5, and they have to be a 4, 1 pair. Yes, just checking in my head, and it's right. and we are going to finish off as a result of having achieved that. It's very clever. I mean, I realise this is a naked 6 because of every digit that it sees in the row and column. 2 there, 6 there, 3, 6, that's a 2. Oh, I can do this 9, 1 before I look at box 9, where I've got 7, oops, 2, 3, 4, and a 5. And that is a beautiful set of polygons by James. Absolute classic James Copp. Actually, really classy throughout, and just an utter pleasure to solve. I hope you had a go at it, because that was great fun. And I hope to see you again soon on the channel. Bye for now.